All right, and we're back. So we're going to get into chapter 7 now. Okay, that's the next step after chapter 6. But I will tell you this: chapter 7, as we get into chapter 7 and chapter 8 and the beginning part of chapter 9, it's gonna travel away from graphing. Okay, we're going to do less and less graphing as we go in these two chapters. Will we graph at certain times? Yes, but it's not going to be like chapters 5 and 6 where you're going to need a piece of graph paper every night. Okay, so we're going to do a little bit less and less graphing. So those of you who are like, I'm done, I hate graphing, the next two chapters are going to be good. It's a lot more like working with variables and manipulating variables and things like that. Working with equations and expressions. Okay. Chapter 7 is all about exponents. And then chapter 8, we get into some things about polynomials. So let's start here with section 7.1. Section 7.1 is called integer exponents. Integer exponents. Let me ask you something. You know, we've seen positive exponents. Like it's obviously like 3 squared is 9, right? What does that mean? That means, just to kind of review, 3 to the second power means the base of 3 repeatedly multiplied by itself 2 times. The exponent is how many times you repeatedly multiply. So if it's 3 squared, that would be 3 times 3, 3 to the second power. So if it was like 3 to the fourth power, it'd be 3 times 3 times 3 times 3, right? You repeatedly multiply it that many times over, right? We know that. We've studied that many times. That's basic review, right? But what does it mean for an exponent to be negative? You know, you repeatedly multiply that many times negatively? Like how can you say like 5 to the negative 1 power, you multiply it by itself negative 1 times? Like that doesn't make sense. What does that mean? How do we do that? Or what does it mean when the exponent is 0? That's what we're going to look at today. Okay, you know, because you may be thinking, well, multiply by itself 0 times? That doesn't make sense. You can use a table to kind of investigate what we've got going on here. But let me ask you this, and you see it on your guided notes here. What's the pattern in the value? What do you see as a pattern in the value? Well,
it's being divided by 5 every time.
Right, it's being divided by 5 each time, right? So 5 to the 5th power is 3125, 5 to the 4th power is 625, 5 to the 3rd power is 125, 5 to the 2nd power is 25, 5 to the 1st power is 5. So, what do you think 5 to the 0 power is? 1. Because if I keep that pattern going, if I keep this pattern going, 5 divided by 5 would be 1. Could I have done this with any other number? Why did I pick 5? I don't know, we just chose that arbitrarily. We could have done that with any other number. We could have done it with 3 or 2 or 4, it doesn't matter. So does it matter the base? If I take anything to the 0 power, won't this pattern, like if I made a table with any other base, this pattern would do the exact same thing, right? So I can kind of, from that, say anything raised to the 0 power would therefore be 1. Right? We'll write that. We'll have that in our notes in a second. Okay, so that's a 0 power. What about negatives then? Well, if this pattern would continue, what would the next box be? What's on negative 5? Well, 1/5. So a negative power is not necessarily a negative number. We're just going to keep that pattern going. What's 1 divided by 5? 1/5. Okay. Nope, just 1/5. And that's a very important thing that we have to get in our brain. Negative exponents do not equal negative numbers. We have to learn that. It's a very common misconception. Negative exponents do not mean negative numbers. Okay, so what would happen with 1/5 now? Wouldn't be 2/5. Well, 1/25. That is correct. 1/25.
Oh, so you're just adding a 1 over top of the numbers on the other side.
Yes, and that's the pattern that we should see. If I keep that going, you know, maybe I'll put this on the board here. If I kept that going, Oh, good, I got a little bit more space. And I took 5 to the negative third power, and I took 5 to the negative fourth power, just so you can see it here, it would be 1 over 125. It would be 1 over 625. So what am I really doing there? I'm really just putting a 1 over top of the power of 5 that I have. So like if it's if it's 5 to the negative fifth power, it would just be 1 over 3,125. And that's the rule that we have, okay? That's the rule that we have to follow. Oh, there's nothing below. Just going on to this. Okay, so this you see on your guided notes here. This is really important. This is the zero power property, the zero exponent property, and the negative exponent property. Zero exponent, any non-zero number raised to the zero power is 1. That's a very important piece of information there. Anything raised to the zero power is 1. Anything raised to the zero power is 1. X to the zero power, 1. Y to the zero power, 1. 20 to the zero power, 1. 1 million to the zero power, 1. Anything raised to the zero power is 1. Doesn't matter what it is. Yes? Even negative. Negative to the zero power, 1. Doesn't matter what number it is. The only stipulation to that, the only caveat is 0. It's actually, interestingly enough, it's actually still undecided. There's still people that think 0 to the zero power is 0. There's still people that think 0 to the zero power is 1. It's kind of undetermined in the math world. There's some people that think one way, some people that think the other way, and they kind of disagree with each other. Yeah.
You can't multiply 0 by 12.
Right, but see, the argument is that if you take like 3 to the zero power, you can always take like 1 times this thing, right? So isn't this just like saying 1 times 1?
Yeah, but where are you getting the 1 from if it's 0?
Because you can always have something raised to the,
Yeah, but 1 times 0.
Right, but if it's not there, it's not 0, it's just not there.
In the first place, it's not there.
See, and that's the argument on the other side. So it's like, there's still people that think one way and still people that think the other way. So that's why we kind of take care of it by saying any non-zero number raised to the zero power is 1. And that's what you see over here too. As long as x is not 0, then anything raised to the zero power is just 1. Okay, now we have negative exponents. Negative exponents. For our purposes here, we can just assume that if I've got something raised to the zero power, it turns out to be 1. Negative exponents. Any non-zero number raised to a negative exponent is equal to 1 divided by that number raised to the positive exponent. Okay, that's the rule down here. 1 divided by that number raised to the positive exponent. 1 divided by that number raised to the positive exponent. This is going to be a very important statement right here. Box that, circle it, star it, whatever you need to do. X to the negative n is equal to 1 over x to the positive n. X to the negative n is equal to 1 over x to the positive n. So basically what we're doing there is taking anything raised to a negative power and putting it into the denominator. See, a lot of people think something raised to the negative power is a negative value. It's not. Anything raised to the negative power turns out to be a fraction. Not negative, but a fraction. Okay? Okay, I have a very, I don't know, it kind of gets on my nerves when people do this. It just irks me. I don't know why. If you say how would you read that?
2 to the 4th.
2 to the 4th power. You know what I hate? When people say 2 4. Like, no. 2 4 is 24. Okay. Or like if you say x, like people say would be like, oh, x9. No. X9 is x9. Yeah, this is x to the 9th. Okay. So whenever we talk about an exponent, we've got to learn the language a little bit. Whenever we talk about an exponent, make sure you say that to that, because if you don't say the to that, then it means something different. All right, so let's simplify a little bit. 4 to the negative third power. Okay, so what should this turn into? What should this turn into?
Fraction.
Good, a fraction. A fraction because I see a negative exponent. And a fraction where I have a 1 on top and 4 to the positive third power in the denominator. Okay. And then we evaluate that 4 to the third power. So I could go to my calculator and say, well, what is 4 to the third power? Remember, in your calculators, this little up arrow symbol, the caret symbol, that is the raising to a certain power. So 4 caret 3, that's 4 to the third power, so 64. So it'd be 1 over 64. So you can put this in your calculator. 4 to the negative third power. But it would give you a decimal, and we don't want decimals. We want fully simplified fractions. Yeah, I understand that there are ways around that in your calculator, but please don't rely on that because you're going to end up setting yourself up for failure later. Do not just rely on your calculator. You need to understand what's happening rather than knowing just how to put it in your calculator. Okay, what's this, everybody? 1. Anything to the 0 power is 1. Okay, that's easy enough. All right, now, I want us to talk about this problem. Negative 5 to the negative 4th power. Negative 5 to the negative 4th power. You know what a lot of people might try to tell me? That the negatives will cancel. The negatives will not cancel. The negatives do not cancel. Because this negative 4 up in the exponent, all that's doing is putting it down into the denominator of the fraction. When I go to evaluate the negative of the exponent, it's really just 1 over negative 5 raised to the positive 4th power. And that negative down with the 5 is not really doing anything, moving it past the bottom. The only thing that that's doing is saying, I'm a negative 5 value. That's it. It's the value of the number, not anything to do with where it is in terms of the fraction. So this would be 1 over, and now I just go into my calculator, figure out what negative 5 to the 4th power is. Turns out it's 620. Oh, I didn't write another one. 625. So 1 over positive 625. And it turns out to be positive because I had a negative number raised to an even power. Okay? I had a negative number raised to an even power. That's why it turned positive. Not because I saw 2 negatives at the beginning. Take a look here. Got a bunch of negative 5s now. And the difference between C and D. What is the difference between C and D? The parentheses. Okay, that tells me that the negative is not included within the parentheses in problem D. So that means I'm really looking at this, negative 5 to the positive 4th power down here. So I don't include it within the parentheses in my calculator. So it's actually negative 625. So 1 over negative 625. See, that turns out to be a negative value because of the negative 5 that was there. And be careful with that. The same rules apply with parentheses. If it's in parentheses, you include it while you take the power. If it's not within parentheses, you do not include it when it's in the power.
Do you take the negative off of it?
No, it's there.
The negative 4.
Oh, yeah. Right. This negative gets evaluated when we move it to the denominator. Yeah. The negative exponent evaluates to be a denominator. All right. Let's take a look here. Again, the difference is the parentheses, right? What's being raised in problem E? What's being raised to the 0 power?
Negative 5.
Negative 5. In problem F, what's being raised to the 0 power?
5.
Just the 5. Okay? Since the negative is not included in parentheses in problem F, then it is not taken to the 0 power. So therefore, since this whole thing is raised to the 0 power, my answer would just be 1. But take a look here. Just this is being raised to the 0 power, so that turns into 1, and then we just bring down our negative. You've got to be careful with parentheses. That's a negative one, not a positive one. Because that negative is not being raised to the 0 power. Just the 5 is. How would we know? Parentheses. If that negative was included in parentheses, like it is in problem E, then you would be saying it's positive 1, not negative 1. So let's talk about it a little bit more. How are negative exponents used then? Right? In real life, like what does that actually mean? Well, negative exponents are used a lot when we're trying to represent a really small number. We're going to study scientific notation here really soon. Okay? And I think you guys would know from your science classes, scientific notation is used when you're studying something that's really, really small. Right? So for example here, 1 cup is 2 to the negative 4th gallons. Simplify this expression. Right? I don't know why anybody would say 1 cup is 2 to the negative 4th gallons. But it's true. It's a true statement. 1 cup is 2 to the negative 4th gallons. Okay, so what does that mean? How do we evaluate 2 to the negative 4th? What would we do with 2 to the negative 4th? How does that evaluate? What would it be? Somebody tell me. What does the negative 4 in the exponent do? Well,
It turns a number into a fraction.
right. So it goes 1 over 2 to the positive 4th. And 2 to the positive 4th, well, that's 1 over 2 times 2, 4 times 2, 8 times 2, 16. 1/16. Is that true? 1 cup is a 16th of a gallon? Yes, that's true. 1 cup is 1/16 of a gallon. Take another one here. A sandfly, something very, yes. Sure. 1/16 of a gallon. That one is hard to label though, because you're just looking at like how they relate to one another. It's a 16th. That's really what it is. Okay, a sandfly may have a wingspan of up to 5 to the negative 3rd meters. Now, think about it. A fly is really, really small, right? How big is a meter, like in terms of feet? What's that? About 3 feet, right? So a meter is about 3 feet. It's roughly the same as a yard, a little bit more than a yard, right? So it's about 3 feet. So if I'm thinking about 1 meter, or think about 5 meters, if you think about it in terms of meters, a fly is really small when I'm talking about in terms of meters, right? Maybe it would be better to use a different, label, right? Centimeters or, something like millimeters, maybe even if I wanted to. But if it's 5 to the negative 3rd meters, let's actually evaluate that. 5 to the negative 3rd would be equal to 1 over 5 to the positive 3rd. See, I take the negative off, and it shoots down to the denominator, makes it a very small number. 1 over 125. 5 to the 3rd power is 125. It's 1/125th of a meter. Which makes sense. It's a very, very, very small unit, about 3 feet. Take that divided by 125, really, really small unit. So negative exponents are used when we demonstrate something that's very, very small. We talked about negatives with parentheses here. Let's evaluate this. Evaluate the expression for the given value of the variables. We have x to the negative 2nd raised to the positive 4, where x is positive 4. Okay. All right, so that means I'm going to plug in 4 raised to the negative 2nd power. I want everybody to evaluate that. No decimals. Write it out as a fraction and then simplify. Somebody tell me, what would it turn out to be? 1 over 16. Good. 1 over 16. Because this would turn into 1 over 4 to the positive 2nd power, and 4 squared is just 16. So it's 1/16. Again, really small number. Take a look here. Negative 2, a to the 0, b to the negative 4. Now, there are kind of 2 ways that we could do this problem. We could simplify this and then evaluate, or we could plug in and then evaluate. Okay? I'm going to do it both ways. I'm going to show you what to do here for both both things. I have negative 2, a to the 0, and that would be times, and I'm going to plug in first, 5 to the 0 times b is negative 3 to the negative 4th power. Well, that would be, what does 5 to the 0 turn out to be? 1. So this is negative 2 times 1 times, and then what do we do with negative 3 to the negative 4th? Comes a fraction. Negative 3 to the positive 4th underneath. Well, if I've got fractions, I can multiply straight across on top, multiply straight across on bottom. No need for any common denominators. That's adding and subtracting. If I'm multiplying here, I can take negative 2 all on, look at all the tops. Negative 2 times 1 times 1. Negative 2. And in the bottom, I have this negative 3 to the 4th power. Now I've got to figure out what that is. I don't know that offhand. Negative 3 to the 4th power, that's 81. Negative 2 over 81. And there's my answer. Any questions about that? Now there's an alternate way of doing this problem. If I really wanted to, I could simplify and then solve. Simplify and then solve. Now what does that mean? I take my original problem. And then I say, work with the variables. Guys, what is a to the 0? 1. I didn't even need to plug in 5. I know that it's 1. And then what happens with b to the negative 4th? Wouldn't b to the positive 4th go down into the denominator? Yeah. So this is what we could do. This is going to cancel out. That's going to be like a 1. The negative 2 is going to stay on the top, and then the b to the positive 4th is going to go to the bottom because it's a negative exponent. And then we evaluate. Then we say, okay, negative 2, and then we got negative 3 to the positive 4th power, which gets us the same thing, negative 2 over 81. I am going to tend to do it the second way, where I'm going to simplify the variables, and then I'm going to evaluate. Let's do that here. Let's do that here. Okay, so this 8, is this 8 being raised to any negative exponent or anything? No, that 8 stays where it is. Is the a being raised to a negative exponent? Yes. Move it into the denominator. Make it positive. What happens to my b? Goes bye-bye. Because it's raised to a 0 power. It's 1. It goes away. So we're left with simplified 8 over a squared. Let's plug in. That gives me 8 over negative 2 squared. 8 over 4 is 2. Questions about that? Okay. Did I even need to plug b in? Right, but 6, 8, like 2 times 1 is just 1, right? So it doesn't really do anything to it, right? Yeah.
So why wouldn't it be negative if you have negative 2?
Because it gets squared. In parentheses, negative 2 squared turns positive. Let's keep doing the same thing. Now, let me ask you this. What if there is a negative exponent already in the denominator? Well, any negative exponent in the denominator, like let's take negative 2. And let's put something else down in the denominator as well. Let's maybe make it like an a to the 3rd. Any negative exponent in the denominator can move up to the numerator, okay? Because I like to think about it as, well, it's going to go, if it was in the numerator, it would actually end up going into the denominator, right? But if it's in the denominator, it's got to switch places. It's got to go up to the numerator, okay? So this x to the negative 2nd will actually go up here and turn into positive in the numerator. So I like to think about it this way. If it's on a negative exponent, it's not happy where it is. I've got to move it. Whether it's in the numerator, taking it down to the denominator, or already in the denominator, making it into the numerator. Okay? So let's do some examples like that. Was there any other one? What's the only thing being raised to the negative exponent? The W. That's the only thing that needs to move. Is the 7 being raised to any exponent? So leave it where it is. You know, this is always over 1, right? So we put the 7 and the Z staying in the numerator. The only thing that moves down into the denominator is the W. Guys, when I say simplify, what I mean there is any negative exponent is technically not simplified. You've got to change it. You've got to move it. You've got to put it somewhere different.
With the negative, yeah.
It turned positive when we moved it to the denominator. Yeah. The negative exponent evaluates when you move it. It goes away when you move it. So that's my answer. How do I know I'm done? Well, I don't see any negative exponents anymore. We'll learn rules on how to simplify things a little bit later as we continue through chapter 7. Well, let's do another one here. What's being raised to a negative exponent? Is the 5? No, it's just a negative number, and that's okay. A negative number does not mean negative exponent. So this moves up to the numerator. It would say negative 5 to the times k to the positive 2 power, and then we would have nothing left over in the denominator. So we would write like a divided by 1 if I really wanted to, but that doesn't really mean anything. It's just a whole number. So negative 5 times k to the positive second in the numerator, in the top.
Why did you put it next to each other, not like in a fraction?
Because this moved to the top of the fraction.
The whole thing did?
The whole k to the negative second moved to the top of the fraction.
Not just the negative 2.
Right. Whatever's being raised to that power moves up as well. With it, yeah. Okay, this is where it starts to get real funky. I would say try to go piece by piece and see if things are happy or things are not happy. What's the first thing that we could do with this A? Gone. Right? That cancels out. It's not like you're just left with an A. Like, it's not like 1A. It's just 1. Just gone. Is the B happy where it is on top? So move it to the denominator and make it positive. Is the C happy where it is on the bottom? So move it to the top, make it happy, make it positive. Is the D happy where it is? So leave it. So that simplifies into C to the third over B squared D to the sixth. Last one here. Again, take it piece by piece. Is the x to the third happy where it is? Move it to the denominator. Is the y to the negative first happy where it is? Move it to the denominator. Make it positive. Is the negative 2 happy where it is? Yes. And I like to write numbers all the way out in front, so I'm going to put it all the way out in front of all the variables. Is the a to the 6 happy where it is? Yes. Okay, what happened in my numerator? Everything left. Good, so it's just a 1. A lot of people might try to tell me that it just goes away and you just end up with just whatever was on the bottom. No, you can't do that. If everything moved to the top, you don't have to write the bottom anymore. But if everything moves to the bottom, you have to write a 1 on top. And that's my answer. Again, please don't mistake negative 2. That is not a negative exponent. That is just a negative number. A lot of people will try to move that 2 up to the top because it's negative. Don't do that. Let me bring up let me stop the recording and I'll bring up the homework page real quick.